We're given f of x equals 3 cosine x divided by the quantity 4 sine x plus cosine x. We want to find f prime of x, the derivative function, and the equation of the tangent line at x equals pi divided by 3. Because our function is a quotient, and this quotient's not going to simplify, we'll have to apply the quotient rule to find the derivative function. Looking at our quotient rule formula, notice f will be equal to 3 cosine x, and g will be equal to 4 sine x plus cosine x. So f prime of x will be equal to, beginning with the numerator, we would have the denominator of 4 sine x plus cosine x times the derivative of the numerator, which would be the derivative of 3 cosine x, minus the numerator, 3 cosine x, times the derivative of the denominator, the derivative of 4 sine x plus cosine x. I'm going to divide all of this by the denominator squared, or the quantity 4 sine x plus cosine x squared. And now we'll find the derivative here, the derivative here, and hopefully simplify. So f prime of x is equal to, our denominator is going to stay the same. So we have in the numerator 4 sine x plus cosine x times the derivative of 3 cosine x, which would be negative 3 sine x, minus 3 cosine x times the derivative of 4 sine x plus cosine x. That would be 4 cosine x and then minus sine x. So now we'll distribute here and distribute here. The denominator is going to stay the same. So we'll have negative 12 sine squared x and then minus 3 sine x cosine x. And over here we'll have minus 12 cosine squared x plus 3 sine x cosine x. So we do have some good news here. Notice how these two terms are opposite, so that would sum to 0. Now let's factor out negative 12 from the numerator. We would have f prime of x equals negative 12 times sine squared x plus cosine squared x divided by 4 sine x plus cosine x squared. Well, sine squared x plus cosine squared x equals 1, so now we have our derivative function f prime of x is equal to negative 12 divided by the quantity 4 sine x plus cosine x squared. And now to find the slope of the tangent line at x equals pi divided by 3, we'll substitute pi divided by 3 for x in the derivative function. So f prime of pi divided by 3 is going to be equal to negative 12 divided by the quantity 4 sine pi divided by 3 plus cosine pi divided by 3 squared. So now let's find these trig function values. Pi divided by 3 radians is equal to 60 degrees. So we can use a 30, 60, 90 reference triangle to determine these trig function values. So this would be pi divided by 3 radians. So we can label the short leg 1, the hypotenuse 2, the longer leg square root 3. And therefore sine pi over 3 radians is equal to the ratio of the opposite side to the hypotenuse, which would be square root 3 divided by 2, and cosine pi over 3 radians is equal to the ratio of the adjacent side of the hypotenuse, or 1 divided by 2, or 1/2. Of course, we could also find these trig function values here on the unit circle, where x equals cosine theta and y equals sine theta. So this would give us negative 12 divided by the quantity 4 times square root 3 over 2 plus 1/2 squared. This would be negative 12. Well, 4 times square root 3 divided by 2 would be 2 square root 3. So we have 2 square root 3 plus 1/2 squared. Let's go ahead and square this denominator. We'd have 2 square root 3 plus 1/2 times 2 square root 3 plus 1/2. So 2 square root 3 times 2 square root 3, that would be 4 times 3, or 12. And then we have 2 square root 3 times 1/2, that's plus square root 3. And then here we have 1/2 times 2 square root 3, that's plus square root 3 again. And then we have plus 1/4. So this product is 12 plus 2 square root 3 plus 1/4. So again, this is the slope of the tangent line. Let's go ahead and clear this 1/4 from the denominator by multiplying this by 4 over 4. So we'll say f prime of pi over 3 radians is equal to negative 48 divided by, we'd have 48 plus 8 square root 3 plus 1. So this is the exact value of the slope of the tangent line. But let's also get a decimal approximation for this. We have negative 48 divided by the quantity 48 plus 8 square root 3 plus 1. So this will be approximately negative 0.764 rounded to 3 decimal places. So now that we have the slope of the tangent line, to find the equation of the tangent line, we still have to find a point on this line. We're only given the x-coordinate of pi divided by 3. So to find the corresponding y-coordinate, we'll have to substitute pi over 3 radians into the original function. So let's go ahead and do that now. So again, now we know the slope of the tangent line, and we also know the x-coordinate of the point of tangency. So to find the y-coordinate of the point of tangency, we have to substitute pi over 3 into the original function f of x, where cosine pi over 3 is equal to 1/2, and sine pi over 3 is equal to square root 3 divided by 2. So we'd have 3 times 1/2 divided by 4 times square root 3 divided by 2 plus 1/2. So here we have 3/2 divided by, this would be 2 square root 3 plus 1/2. Let's go ahead and multiply the numerator and denominator by 2 to clear the fractions. So f of pi divided by 3 is equal to 3 divided by, we'd have 4 square root 3 plus 1. So again, this would be the y-coordinate of the point of tangency. So now to find the equation of the tangent line, if we use point-slope form of a line, or the form y minus y sub 1 equals m times the quantity x minus x sub 1, we would have the linear equation y minus 3 divided by the quantity 4 square root 3 plus 1 equals the slope times x minus x sub 1, or x minus pi divided by 3. Now if we did have to have this in slope-intercept form, we have to distribute here and then solve for y, which would look like this. We'd have y equals our slope times x. Notice the next product would be positive, so we'd have plus 48 pi divided by 3 times 48 plus 8 square root 3 plus 1. And then to solve for y, we would add this fraction to both sides of the equation, giving us plus 3 divided by 4 square root 3 plus 1. So in slope-to-intercept form, this would be the slope, and this would be the y-intercept. I hope you found this helpful.